Hey everybody, this is Larry. This is the 28th Leetcode Biweekly Contest. Let me know what you think. Which one was your favorite problem? Which one did you have trouble with? Was there dynamic programming? I guess we'll see. Hit the like button, hit the subscribe button. Wish me good luck. I'm gonna do this live, obviously. And we got about 10 seconds to calm down, to stretch, to I don't know, get comfortable, right? Okay, well now there's only 3 seconds, so wish me good luck again, and I will see y'all in a little bit. And here we go. Okay, Q1. Okay, Q1 again, because apparently I had some trouble loading. Again, having issues with loading. Oh, no. Yeah, oh no, what? Yeah, no. Okay, Q1, final prices with a special discount in the shop. So this one is a tricky one to read. I mean, because like I said, we'll say later, it feels like I'm doing an SAT question. There's a lot of reading. I don't know what's up, and it's a lot of reading for the first. And one. Yeah, but other. Given that n is equal to 500, you could just do a really basic 500 square problem solution where you just go for each number, go to the next number, or find the next number that is smaller than the price, which is the directions, and then that's pretty much it. I am still reading this problem because I wasn't sure what it's really asking, to be honest, so yeah. Okay. That is a lot of reading, but okay. But once I saw it, I was like, okay, let's just do this, right? And I wasn't sure if we want the biggest discount or the first discount, which apparently is the first, but when I saw it, I wasn't sure yet. My current chair is very quickie. Sorry. Yeah, I'm typing really slowly today because I wasn't sure. Also, I don't know why I did n+1. The inclusive exclusive stuff has been kind of in Python. It's a little bit just mixes me up a little bit. Max number. Yeah, this really is just two for loops, and for me, I probably consider myself doing this a little bit slower than I would normally. I would say I did just get back from Hong Kong, so I'm a little bit sluggish. I'm back in New York, yay! So maybe that's why. Hopefully, once I shake that out of myself, I'll be able to perform a bit better. But yeah, it's just the first time that this happens. I break. I'll put the break first, but basically put in the answer. And then otherwise, and in Python, there's an else statement for a for loop where if everything executes in the for loop without the break, then it puts it there. That's pretty much it. I ran the test cases. Again, I don't know why I did n+1, but after I fixed that, that's pretty much it for Q1. Submit, done. Q2, sub-rectangle queries. So this one, the first thing that I looked at was just seeing whether we can brute force it, right? It's Q2, there's some meta stuff about it during the contest, and the question is, yeah. The question is, can we brute force it? And the answer seems to be yes, because 100 times 100 times 500 is at most 5 million, so that's pretty much what I did. And I did this one actually faster than I did Q1 because I don't know, the reading was more reasonable, so I was able to code like as soon as I got it. Where Q1, I just kept on reading the problem, but basically it just goes for every place from rows and columns and then updates it to updates it to the value that it tells you to update it to. But yeah, and then after that, that's pretty much it. Q3, find two non-overlapping subarrays each with target sum. Yeah. So this one, I think I spent a good amount of time just reading it as well, as you kind of see here. So the thing that I was trying to figure out is just, well, the non-overlapping part. I think that's the quickest part. The thing that I looked at was, okay, what is n? Can we do anything brute force? Well, n is 10 to the 5th, so you have to do something in linear or n log n. And then the second thing I look at is target is positive, right? And what that means with target is a positive number means that, well, then you could do greedy with a sliding window. And that's what I did here. That's what I start by doing. At first, I was just going to keep track of all the lengths and then just like pick the last two. But I knew that I didn't need to do that, but I don't know. I mean, it's just template or like mental putting it there just in case I need it later. But here I am doing the sliding window for each right, and you could have done this with prefix sum is the same thing. But when you basically with the sliding windows is trying to find the invariant for targeting, and basically when you process an element to the right, you can add that number to the current segment. And then if that current segment, the sum of that current segment is bigger than the target, you can subtract it from the left until it is either equal to or less than the target. And you could do this because target is positive, so that that condition will always hold. Otherwise, you might have to do some dynamic programming version of it. And yeah, and just moving the indexes obviously, because I always forget it. But yeah, now this is the fun part. And then what happens when you go to target, right? Well, I was like, okay, let's just put the segment in there, because by the time I typed this, I was like, okay, you have all these segments, and you want two of these segments that are not overlapping, and then you want the smallest version of those, right? So that's what I'm trying to do here. By the way, if you're still watching this, note that there's a full description at the link below, so that you can explanation of a link below. So definitely check that out if you're impatient for whatever reason, which is fine. But for now, I'm going to talk about my thought process and not necessarily the solution, because for me, I think it's interesting, or possibly interesting, maybe not if you're fast forwarding, kind of my thought process. And here, I just wanted to print out. I just wanted to print out the segments just to make sure that I was okay with off by ones and stuff like that. And it looks like I was okay. So I was like, okay, let's jump to the next step. I was trying to keep mins. I was trying to be a little bit not clever, but I don't know if it made sense. Now I'm trying to think, let's say we process the segments one at a time. What does that mean? And I was like, actually, we want to process them from left to right. So that means that I want to process the events anyway. So then now this is what I do as a sweep line algorithm. And basically it opens on the left and then it closes on the right. And then you do some processing on the left and the right, but I actually messed this up a little bit, as you will see. I mean, so right now I'm thinking through what are the cases. You have to sort it first, but I really should have spent an extra minute thinking about it, to be honest, because I end up with two wrong answers because I wasn't really clear about how I wanted to implement it, or at least the edge cases that I want to. At this point, about 10 minutes into the contest, I was very much rushing it. I thought that I had to be a little bit faster, though. In retrospect, I didn't need to, but I was feeling that pressure. And this is wrong. This is just if there's no more segments, we do the delta thing. I don't know why I thought this was correct, but basically what we want to do is we want to handle the left endpoints and the right endpoints in a different way. But what I was thinking was like, okay, when the delta is 0, meaning when we're no longer in any elements, then maybe we can process the minimum in some interesting way. And I think that the rest of the idea makes sense. It's just that I don't know why I, and sometimes when you're wrong, you don't know why in retrospect. But you, especially with these algorithms, which are a little bit, I wouldn't say greedy, but greedy in nature in the processing. Especially with sweep blind, it's generally going to be greedy in that way. But yeah. But this is well. Somehow though, unfortunately, it matches the answer from the results. But there are a couple of things I have to do. I have to check that it is. If it's not possible, then we turn -1, which is the infinite number. But I also have an off by 1 somewhere. That's all. Mostly that I was checking delta and not the current, which was wrong altogether. Because that never gets caught as a result. When the code, it looks still wrong. And I was like, huh. And it turns out that I just had an off by 1 because my right, I mean, you'll see me fix it very quickly. This is not a trivial thing. It's just an off by 1 because I was like, oh, yeah. Because I do right minus left plus 1, but right is already exclusive, so I didn't need that case because I add 1 afterwards. Which is sometimes tricky to catch, but I mean, I knew that was the case. Kind of. I knew that that's a possibility, but I wasn't sure that that was the only bug, and that's why I'm hesitating right now. And that's why I just want to print it out just in case. Because I was like, oh, 0 to 1, that's exclusive, so we definitely need to fix that. I was also thinking whether I should just put the right later, but that's fine. But yeah, so now that looks good, which is a little unfortunate because that's why I submitted it. But I still had a, I don't know. I think I was just not I mean, to be honest, I was just really, just like some of it is jet lag. That's my excuse. I'm sticking to it. But also some of it I was just careless because I was rushing it. I really wanted to get a high score, if you will. And when you rush things, sometimes you like I definitely could have tested this case, and there was another case that I could have tested that was very much obvious, which you'll see in a little bit. Spoiler alert, but by once. But yeah. But basically, because I had an off by 1, well, not off by 1. It's just that. So the first one is just this is actually just wrong. It wasn't off by 1. It was that basically if I have overlapping things, but or better if I have A that overlaps with B and then B that overlaps with C, C does not process the number in A. So that was the problem that I was running into. But and yeah, I don't know why I thought that that would work. To be honest, this is one of those things. But that proof by AC. And then now I'm like, okay, if the delta is -1, meaning at the end of a segment, then we can do it, right? And that's just kind of, I test this, but I should have tested more cases. But like I said, I was rushing it. I was hoping to get a good high score for my friends out there. But that I click on submit before I really test some basic cases, especially after one wrong answer. Getting one wrong answer, sometimes I'm okay with it, but getting two wrong answer is me not being responsible, like not being a responsible person. I am responsible for it, but because I was like, okay, this is such an obvious case when you see it too, right? It's just literally, and that's pretty much what I do for the next 5 minutes. I actually resolved it. There was actually an easy way to fix this, which is by, and I go over it in the explanation later. But which is that I had to treat the beginning segment and the end segment differently. But I was just rushing it. I was just trying to get an answer because I knew that I was close, and I was close. But when you I think it's just a mindset thing. When you're like 95% of the way there, the last 5% of the way, you're like, okay, let's just do whatever works to get the last 5%. But sometimes you need to make sure you get that last 5%, and I didn't do that, and that's why I got two wrong answers, and it was really sad. As you can kind of see me being a little bit frustrated in that regards. But yeah. And now I'm just thinking, like, can I hack this? And the short answer is yes, but I think I had in my mind that those two things have to be together. And then I was just like, okay, let's reboot how I think about this problem. The sliding window is correct, so I didn't need to fix that part, but I just need to handle the left and the right in a better way. And that's what I end up doing. Still thinking it through. Like I said, I was still trying to think, but I wasn't really clear about it, to be honest. But yeah, but now instead of trying to figure out the left segment, I was like, okay, let's just, for each left segment, we just keep track of where it begins, and then we only process the left part when we get rid of it, right? When it no longer overlaps or possibly overlaps with the current going from left to right, then we can track it or we can use it. So that's basically what I do here. The idea is that, okay, once we increment left past that, then we know that we can be like, okay, whatever's in there, it could be the min segment. So let's, put it in there, and that's what I have the min for. But yeah, and the right minus left is just the segment that's inside. So yeah, I ran it. Oh, yeah, I forgot to. I guess I deleted earlier. Yeah, it looks okay. I mean, it looks wrong. So I was like, oh wait, that is still wrong. What is going on? Oh man, the good old print statement. Like I usually say, when if you have to debug during a contest, it's always a sad thing because you never want to debug. It always takes way too long versus coding. But sometimes when you need to, you need to. On the right. But yeah, the short answer is that there's just an off by, or yeah, I set the. I was putting the left and the right in the same thing, so it didn't make sense. But yeah, and also right is exclusive, so I fixed it off by 1. So that basically, your right would put in like, okay, this is the segment, and then when the left gets processed, then we're like, okay, this segment is actually good. That's basically what this is trying to do. And I was like, still okay. At this point, I was not confident. Obviously, after 2 wrong answers, it's hard to be confident. But I was like, okay, let's just try this, and really quick, fingers crossed, and then I get it. So that was pretty good. A little bit relieved, but yeah. But this is Q4. I've gotten it. Excuse me. Q4, allocate mailboxes. So this is a dynamic programming problem. Just also as a reminder, you can fast forward to the end where I actually explain this problem in depth actually. But so what you're going to see in the next like half an hour even is just me doing this live and me explaining my thought process as I'm trying to solve it. And I took a long time to figure out this problem, so the commentary is going to be just as long. But if you're here just for the solution, definitely go, click on the links below, find the answers, and then let me know what you think. Cool. We allocate mailboxes. So this one, I had a couple of things to that I wanted to think about this one. There are a couple of things for this one to think about. It's dynamic programming. I knew that it was some variation of dynamic programming. Total distance. Okay. I didn't know. Oh yeah. So initially, I thought that you have to return the maximum min distance, which you can solve with binary search, because then you just search like, hey, is the maximum distance 10, and then just greedily put houses down, right? So that would have been one way to do it. But then I was like, oh wait, no, it's the minimum total distance, which is a different problem. So I'm really happy that this time I solved the right problem, because I definitely, there's been a couple of times before where I rushed it and then I did not solve the problem fast, or like I solved the wrong problem and I had to rewrite it from scratch. So for that, I am happy about this one. Yeah, so there's an observation that I am trying to make here. Some of that is because I have solved a similar problem in the past a long time ago, so I don't remember exactly the details, but I do remember, I do have some recollection of it, and that's what I'm trying to think to myself. Like I have what I call you're given this problem, right, and you have this texture. And what I mean by texture, and is a word that I use that I think no one else does in any way. So if you hear, it's from here. But what I call the texture of a problem is that, and why I call it a texture is that you have this feel when you see a problem and when you sense a problem and you feel this problem and you have some intuition about some properties about this problem. And then and a lot of times this will come from previous practice, observations that you made last time and you proved to yourself last time, right, that it is correct. And for me, I did probably do something like that last time, but that was a long time ago, possibly years ago, possibly decades ago, when I last solved a similar problem. But I did still have that intuition. I still have that, like, hey, I think this may be true. You should take a look at it. And that's kind of how I thought about it. And my intuition is, and you can do this mathematically as well. There's nothing like, I don't want to make it too too mystical about like all these experience and so forth. But what I want to say is that that it always makes sense to put. So yeah, so there are only a couple of cases to break it down. One is you put a mailbox on a house, or you put a mailbox between two houses, or no houses at all, right? So those are the things that I would think about. And then the reduction that I was trying to think, and again, I go over this in more details later in the explanation. But I was just trying to convince myself at this point. Okay. The first thing that I did was sorting the array, so that it's from left to right is increasing. That makes sense, I think, in the sense that if it's out of order, it's a lot harder. So the first thing I was trying to think, right, was what I just said, which is that that when we put it that way, where we put a mailbox either on a house, in between a house, or not between these two houses, so you have to put it in the forward, right? Once you do that, it breaks down the question of like, okay, it breaks it down a little bit. But I did actually, before that, I forgot about this. Sorry about this. This commentary is a little bit of my memory, but what I try to think is, okay, let's go from left to right, and then do some divide and conquer, right? Like, okay, what's the maximum distance of left and the right if we put a mailbox here, right? And then I was going to think about maybe doing it that way. You could maybe think about the same idea for burst bubbles or something like that, or burst balloons. Yeah, those kind of problems where you divide and conquer dynamic programming. And then the reason why I stopped was I was like, wait, because we're given a k in this problem, then the short answer is that it's going to be too slow. Too much space, too slow, because it's going to be n to the fourth. So I was like, that doesn't make sense. So then now I pivoted to the, okay, because you can always process a house at a time, either putting it in the beginning or at the end or whatever. Then yeah, then you can just process the houses one at a time. And that's kind of what I try to do. I would say though, I did have a little bit of I didn't understand this problem in the beginning, even though I got the code, say 80 to 90% correct, but it wasn't 100% because I was missing one understanding of the problem, which is the edge cases. I think in dynamic programming and sometimes in sliding windows and stuff like this, it is very important to think exactly how you want to define the problem. And what I mean by that was that what I mean by that is that because my index isn't clear, even though I wrote the name of my method is getMin, I have the index, I have the k, and it's mostly right, but I wasn't thinking about like, what does it mean? Is it like, do I put a house on index every time? Do I skip index? Is the last house on index? So these are things that are nuanced and obvious to ask, but if you don't ask yourself, then it affects your base case. It affects a lot of things. And for me, my issue was just thinking about what the index actually meant. And even though I was really correct, because I was mostly correct, but not 100% correct. But I was mostly correct because I was carried by my experience in a lot of way. Because of my experience, I was like, oh, I think this is roughly right. But I wasn't able to be actually right, which is the more important part, because I didn't know how to define my edge cases, because I didn't really define the problem. And when you don't define the problem, it's hard to define the subproblem, right? So yeah. But yeah, so at this point, and even though the code will look really similar from this moment in time and the end result, what I said was still true, which is that I didn't define the problem very well. And because I didn't define the problem very well, and also I have a typo, but because I didn't define the problem well enough, or I just didn't define the right problem, even though the code looks very similar, I wasn't able to solve it in a long way. And you will see me try to hack it to solve that for that reason. But the short answer was that I didn't define it. And how did I define this problem? The get min for me right now is um, a sort of a prefix. Okay, so basically we have no houses, and we just put in an index. What does that mean when we put in an index? Or like a house on house of index, right? So I do this thing, which actually was wrong, is wrong, still is what it was wrong and still is wrong. Um, but basically what I was trying to do was, okay, let's say this is the closest house to up to y, up to house y. But I was doing this in an asymmetric way. Or sorry, I assumed some kind of symmetry where where it's asymmetric. So this was not right. And here in this point, I just wanted to run it just to kind of see if it works. I was just being dumb because I returned infinity in at the bottom of the function, so it was always going to return infinity. Took me a couple of minutes to debug this, which is unfortunate, but yeah. So now I saw the one case where it's wrong, so I looked at it. I was like, okay, what is what's up, friends? Um, I was like, oh, it returns correctly, but it's just like I said, it wow, I spent a whole 2 minutes debugging a typo because I just returned infinity, like at the bottom of the function instead of best. Um, I think now I realize this after I type this out, but uh, again, I'm gonna blame it on my jet lag and rust. So I was like, oh, this returns 14. Why does? Yeah, okay, silly Larry. So I printed it out and I was like, okay, it gives me an answer. It's not the best answer, but that's okay. I just wanted to. I knew that I was missing some stuff, but I just wanted to see how what's up. And so the reason why this didn't work was I was thinking about because we always put an index. Oh, geez. That was the doorbell. Sorry about that. And it scared me a little bit. Hopefully, I don't know. Usually, I don't get anyone visiting, so it probably is just the mail or something. Um, but yeah. So the reason why this was wrong was that I always, and this is what I was talking about earlier about being clear about how you define the problem. I didn't define the problem clearly, so this is the issues I'm running into. One of the two issues that I would have to fix, and those two issues cost me like an additional half an hour and a wrong answer. So 35 minutes of penalty because like if you look at this code now, it is very similar to what I have later. But I was just missing the clarity. And what it's saying is that because I forced myself to always put my house down on the current index, I was trying to get away from that. Be like, okay, let's say I don't put a house on the current index, and that's what this if statement does. And I was like, okay, this looks good. Is this good enough? No, because that's the wrong answer, I think. in a good way, because I would have totally submitted it. And the reason why this doesn't work is because the way that I did the totals, if you process a house, you don't just take the delta, you have to take the delta of all the other ones, right? So that's basically what I did. But this is still wrong. What I did was a hack, and I was just lucky that it passed the system testing. Oh, not the system testing, the example cases. Because I knew, I was thinking about this going forward, but yeah. But yeah, so I did figure this out. Now I submitted, and it was a little bit sad because I was like, okay. So the first thing that I questioned was whether oh, I did actually, sorry, there was one thing that I missed, which I again do talk about later in the explanation, so definitely fast forward if you want to go to it. But was that that in between two houses, the best way to place
couldn't prove that I needed
a mailbox, if you want to put it between the two houses, it is equivalent to putting it on one of the houses. And I will, and in the explanation later, I will show why that is the case. But that's the observation that I made, and I was thinking through that is why that's an observation that I made, and also something that I just have experience in the past, so that basically in the past allowed me to kind of do this, and then the reason why I'm bringing that up now is that as a result of this wrong answer, I was just double checking, and I actually later in a couple of minutes will take a notebook to kind of look it up, because I was second doubting, like, hey, I do have recollection that this is true, but maybe it's not. Maybe I need to prove it again. And then I did prove it again later on paper, but I was a little bit doubtful. Like, I was like, maybe you do need to put the mailbox in between two houses instead. But you could prove to yourself, and I will show it a little bit later, why it always makes sense to put it in the house. But what happened was that I was double counting some of the stuff, and what I mean by that is that given this case, I don't know, my formula is just wrong. That's pretty much it, because I don't keep track of what's on the left, and if you just multiply it by index plus 1, it overcounts the stuff that are matching to other houses in the past. So that's why this is wrong. Yeah. So at this point, I am going to skip ahead. There'll be a link below so that you could skip ahead with me. But basically, I go through this and I do. I write on paper and try to prove to myself that's correct. I will see you after the skip. If you want to fast forward or if you don't want to skip, that's fine too. Watch Larry struggle. But that's just my heads up. Where do you put it? That's the question. should get 12. I don't get why it's 9. Oh, I see. Okay, I see the 9. It's not, this is not quite right. It's too slow. That's what I was wondering before, but I guess when you need it, you need it. That's too slow, I think, and I got a phone call. Okay. He's too slow. Yep. Hmm. Missing one frame. This is 9, right? And this is 8. This is not right. This is not right. Same complexity. Hey, so getting right back to it. So I think at this point I was trying to figure out different formulas to kind of solve this problem. But I think at the end of the day, I just did not have, still at this point, not a good clarity on how I define my dynamic programming function. And I was trying to, the last 10 to 20 minutes, what you saw was just me hacking away, trying to be like I said, like sometimes you're 90% of the way there. You're like, okay, maybe I could just, YOLO, try different things, and the 10% will magically appear. And sometimes if you have enough practice, that will happen because your intuition and your experience takes over for you in a way that you might not have realized. But if you don't formulate the problem correctly, you're not even trying the right things. And that was my problem, even though my code, as it looks now, will be very similar to what it looks later. The formulation changes the base case, and the base cases changes the formula. The formulas, will be why I was wrong. And here, what I realized was that I always put. So I mean, if you watch what I was trying to do, I tried different ways to kind of get around needing to put a house. Also, I put a mailbox on every house, and on the first house even. But then I was like, okay, how do we deal with the beginning case, right? Well, the beginning case would be that, your first house. So that's what I was like, okay. And it took me a long time to get to this point, was just separating out the test cases or the edge cases between the first house and the last house. And the first house is, as you can see, I just put a for loop to fix that first house, where I'm like, okay, let's put it in the first house. And then my formula is actually still wrong. But because I still didn't formulate the formula correctly at this point, I was able to kind of start to formulate the problem, but some of that it's still kind of, because I was doing the same. I was just trying to do the same thing I was earlier, but a little bit different, right? So that's why. And I just ran it just to see it. I mean, I knew that wasn't going to be correct, but it gives you a sense of. It tries to give you a sense of like the feeling of a problem a little bit better, and that's what I was trying to do here. But yeah, now I beginning to formulate this in a different way, which is, let's just treat, because before that I was trying to put the houses, like I was trying to do things too cute in a way, in a generic way, such that I was trying to do things in a way such that the first house and the last house,
Just
what should we call it?
9 or something.
The first house and the last house the same way, right? Like I was trying to make generic how we handle the first house and the last house. And in a lot of dynamic programming problems, in my experience, you can do that. And some of that is because I maybe haven't practiced the harder dynamic programming problems in a while. So that's, again, talks about practice. Like Larry, and that's what I hate about when people talk about patterns and stuff like this, is that even when you don't consciously try to do patterns, sometimes you do fall into things where you're like, okay, like I've done, the last 20 dynamic programs were like this, why is this different? And if you don't, and it took me some time too as well, if you don't think back and be like, okay, how do I fix this, or why is this wrong, or have the components to build this up correctly, then your edge cases are wrong, and that's how I was not doing it correctly. And I was still not sold, as you can see, but then I was like, no, this is right. Or maybe not, I don't remember what I was thinking, because I was going back and forth clearly. I just wanted to see the answers, and I was like, okay, this is clearly not even close to right.
Today's just not my day.
But one thing is that my base case formula is wrong. That's why I was having a little second weirdness about this. And then now I'm just rethinking, like, okay. And on line 31, that form is wrong, because you're supposed to for loop, the distance from, like, the cost of putting the first house at Y is the distance from the 0th house to Y, first house to Y, second house to Y, and so forth, right? But I do not do that. And I thought that this one I was a little confused about. I think I was just a little off by 1, so I was like, oh, I just need to, but the formula was just wrong in general, so. So it was the formula that was wrong, but I was uncertain about. I was still stuck on that prefix formula, but I definitely did not need a prefix formula. I was like, no, this is, and I just undid some of the stuff, but. And then here you see me kind of just going back and forth. And kind of the really surprising thing is that right now, I mean, I know that we've been at about the same amount of code and same amount of percentage for a long time. But right now, it feels like, it feels like the end. And we're only a couple of minutes away. Like, it feels like we're stuck, but it only took a couple of minutes until I submit this problem successfully. So sometimes, grind through it. What I want to say is, grind through it, work hard, because sometimes the solution is just a couple of minutes away, even if you've been struggling for a long time. And here, you will see me soon come to the realization that my formulas are just like, what am I doing, Larry? Why am I doing this? I've been like trying to go for this the last 25-30 minutes, because my formula was just a little bit wrong, or a lot wrong, and I just needed to second guess. I was like, this cost doesn't really make sense. Like, I was trying to. So this is a common concept that comes up in dynamic programming, and that's why I was trying to figure out how to do it this way, which is that these costs, you could break them up from different components to sum it up together in an easy way. And when you do that, why do you do that? The reason why you would do that is because it saves you over n times. I explained this a little bit later again in the explanation, but basically, if I had did it the naive way, it would have been O to the n to the 4th, and we need to get it to n cubed, and that's why. And that's the reason why I was struggling a lot with this. But then at this point, now I was like, oh wait, you could just brute force this, or not brute force this, you could just pre-calculate this. And that's kind of what I did. Well, for the first thing I did was I wrote the right formula for the first house, because you saw that the formula was just incorrect for a long time. But yeah, now we're subtracting it from the index instead of from the left. Because we've just got that wrong for a while. Yeah, I was like, do I need this? I could just put it in the folder below. But then I was like, yeah, it's okay. This is kind of true. Just leave it. It's fine. And even though I did an LRU cache here, it is not necessary, because you only ever do this once for every function or every input. I believe. And then I was just trying to think about like between the left house and the right house, and then for this one I was like, oh wait, you don't need that because this is the first house. You only use it for the first house. Here is where I need it, and that's where cost 2 is a crappy name, but and I was still thinking a little bit about how to merge them together in a good way, but at the end I just broke them down to 2 different functions, and then I was like, okay, this is just cost index of y, and then now double checking the index, I was like,
Oh, that's not right.
okay, double checking the index after this. But at this point, I was wrong on so many things that I was just like taking my time, like in the beginning, the 5 minutes would mean a lot of difference in rank, but here I was just like, whatever at this point. And then I was like, oh, no, you double count index. So just 2 plus 1, yeah. And then I was like, oh, that looks good. And then I submit and it actually works. So like I said, always keep fighting. Chat about the library explanations coming up, and I will see y'all. Well, the other library will see you.
That was dumb.
I just tried to find shortcuts of the maps, but I didn't find one clearly. Let's see, I didn't do that well. That's okay. I actually did legitimately struggle with Q4. Funny, I mean, I probably got like 90% of it very quickly, but I think I was trying to optimize something that by overthinking it, I knew that I could have just cached the things, and that would have been fast enough. I'll go over why in a little bit. Okay. Guess I didn't finish fast enough for the code force, so let me catch a breath and then think about what I did. I really should have done this one faster though. And Q3 was just silly. Yeah, well. But yeah, well, if you're still watching, thanks for watching. I'm going to do the explanation of the code now. I'm just taking time out. I mean, it's okay. It is, to be honest, a technique that I haven't, not that I haven't done before, just haven't practiced in a long time. So I feel okay about that. Still 40 minutes is a long time though. But I did the first 2 problems pretty quickly. No, I mean, I think that's unfair though, in the sense that I think people are trying to probably did this in a more clever way. Q3 was killer. Q4, I don't know. I should have been okay, but I didn't. I mean, it was a grind, and sometimes you just have to grind. But man, whew. Okay, let's go over the problems. Q1, final prices with special discount in the shop. So basically this one I did brute force because N is only 500. The idea is that you just try to find the next item that is smaller than the current price. And there is a linear way of doing it, I think, maybe not, with a mono queue or mono stack or something going backwards. But it's not necessary for this problem. I didn't really think about it that much. It was just a lot of reading and yeah, it's like taking the SATs in here. but the short answer is for each index, look to the right and then keep going until you see a price that's smaller than the current price, and then subtract that from the current price. That's pretty much what I did. And like I said, there was some reading comprehension in it, and the internet was a little bit slow in the beginning. I don't know if you've seen, and that forced it to be a little bit slower on the timing. But otherwise, pretty straightforward problem. Pretty cute problem. My algorithm is n squared. You could do it in linear time, I believe, or even n log n, even if you're a little bit lazy. But yeah, that's Q1. Cool. Okay, Q2, subrectangle queries. So this one is just brute force again. I don't know if this is, I mean, there's probably a smarter way, and there's probably a way to renormalize the matrix, but I just did the math where rows times columns is, well, rows and columns are 100 each, and then times 500. That's only like 5 million operations, so like that's way fast enough. So I just did on update, I update the values, and then on get value, I just return the get value. And this is sadly really straightforward. Cool. Q3, find two non-overlapping subarrays with target sum. So this one was a very tricky one for me. Mostly just off by one errors, or not off by one, but I had an idea on how to solve this, and I did it 2 different ways by accident. Yeah, and I spent 10 minutes debugging, which is kind of unfortunate. But the idea is that, well, the first part is just sliding windows, right? And then from the sliding windows, you just look for the target equals to target. The first thing to note is that target is between 1 and 10 to the 8th. But the key thing from that is that it's positive and it's not 0. So therefore, one sliding window processing it's good enough, because you could do it in a greedy way. So that's how I did the sliding window part. And then the overlapping part is a little bit tricky the way that I did it. And I end up just tracking the minimum. I could have done this a little bit differently with like a heap or something like that, and this would make this a lot space efficient, though time a little bit slower. But the idea is that for each element, if this is the left part of us, so basically how I would think about this problem is you have some overlapping segments. And you might have seen how I tried to attack this problem earlier as a result. But basically, you know, you give it an array, and then now you convert it into segments that or subarrays that have target equal to sum. So let's say these are both 3s. You have 1 to the 3, and then you have 1, 2, and then 2, 1, right? So you have all these overlapping arrays. The thing that I was trying to do in this problem is change it to an event-based system where, okay, so every time a full segment is finished, we put it into we count that as a possible candidate for the min, right? And then we just keep on doing that. So for example, here the min is 1, here the min is 2, but then we throw it away because it's not min enough. Here it's 1 again, or 2 actually, sorry. And this is 3 because, yeah, it's inclusive. So this is 2. So then here it's at 2 elements plus the previous min, which is 1, so that's 3. And here again, but this one, here, we do not, I think I had an off by 1 error now that I think about it. but we do not pop that yet until the very end, until this element is processed. And then now once that element's processed, then we can we can use it. So for example, let's say, I'm just making up examples here now, but let's say, you have something like this. These are all overlapping segments. So now you process this is the min. Here you process this, but then here you do not update the min yet because we do not process the right endpoint yet. So we're going from left to right, sweeping line. So here it goes, okay, that's okay. We started at the beginning of a segment. Here we begin of the segment. And here we end the segment, though I think you have to do this one first, so it doesn't end it. So here it begins a segment, and here it ends a segment, and then this updates min here, which is, I don't know, 4 or 5 or something like that, right? So it updates the min, and then when we go to here, it also updates the min because this segment is smaller than this segment. But then here, but let's create another segment so we could illustrate a little bit better. But let's say we're up to here. Well, now we can check the size of this segment times plus the min, because here we know that everything that's already updated in min already contains the minimum segment, and here we just check this segment, like this segment plus a previous min segment is good enough. So that's what this is saying, and then here, here, that's okay. We update the segment. Let's move this a little bit back. So then here again, when we get to this point, we update the min again. And then here, we take the min from this segment and the smallest previous min segment. So that's basically my algorithm here. Basically, we have a sliding window and a different thing to process for the left endpoint and the right endpoints. I think I don't know why I didn't really think about it that much. I think the way that I did it the first time is right. It's just that I was trying to merge two things at once. So how I would have redone it the way that I did it was actually with the two events, say. So this is okay too, obviously. But if I had given a chance to do it again with the event stuff, and you even see the events away, but we append the left, one for increasing the segment, right minus left. This is a little, and then the right. So we have something like that, and then now we have events.sort, and then for was it x, though we never use it, delta, and then segment or size in events. We can do, well, if delta is equal to +1, which is the beginning of a segment, well, what do we do when we enter a new segment? When we enter a new segment, we go, okay, let's take the ends is equal to min of ends, the current previous min plus the size. And then if delta is equal to -1, well, then we get to update the min. And that should be good enough, but and this is n log n versus O of n, it would have been with the other one, but it's still so much cleaner and so much less error prone once you really get to understand what it's trying to do. I'm not going to submit it, though actually I guess I should run this example test. I'm not going to submit it because the contest is still going on and I don't know what happens, but I'm relatively sure this is right now that I understand it a little bit better. I think in the contest, what happens sometimes is that for me is that you really want to get a high score, and then you rush through things, and then when you rush through things, you miss it a little bit. I was trying to combine these two things into one place, but I didn't really I had the idea in my head of what I knew that I had to solve this problem, but I didn't really visualize this well enough to be like, okay, on the left endpoint do this, on the right endpoint do this. What I did was that I just was trying things out until hoping that it was okay, and that's how you get 2 wrong answers. And was it 10 minutes of penalty on this one, where if I just stood back and really think about it, I could have gotten this trivially, and instead I did that other thing. But that's all I have for this problem. The way that if you do it with the defense basis and log n, because you have to sort, though you could maybe do a little bit clever with the way you insert things, because you're going left from right after all. But of one space, so that's, oh no, sorry, I lied. This is of n space, because for each n there's for each n well, it's up to O of n space, but yeah, for each target, I guess it could be O of n. Or for each target, it'll be O of 1, so there'll be O of n possible targets, because, for example, you have just all the numbers are the same. But yeah, and you could have reduced this to O of n as we did before. For the running time, the space would be the same. Cool. This is a really tricky problem, at least for me. There's really a lot of places for potential off by ones, especially when you try to rush it. Definitely when you solve these problems, make sure you get it right. Getting it right is faster, faster than getting it fast but wrong, right? Obvious, but still, I still make that mistake from time to time, right? So yeah. That is Q3. Definitely good practice. I like this problem, actually, to be honest, even though I got 2 wrong answers. And it's not too hard, it's not too easy. You just have to really think about the edge cases and how to break down a problem, because they're, in a way, you're solving 2 different problems in one problem, and that's where the difficulty might come in. Cool. Q4. Let me adjust the mic real quick. Q4, allocate mailboxes. So this one I really was sad about, mostly because I knew what I was doing and I knew what I wanted to do, but I just didn't, for some reason I didn't do this thing here. I was trying to put everything into one formula, and that's why I was wrong, and that's why I took a long time on this problem, because I think I got the rest of this pretty quickly, and I really probably should have done this a lot faster. But I think sometimes sometimes practice and experience comes together in a weird way, and what I mean by that is that I have solved a similar problem before, which allowed me to figure out the properties and the constraints of this problem a little bit better. But because I solved this problem before, I had a wrong or just a little bit incorrect memory about how to do it in a linear way, and as a result, I was not able to do it in a very good way, because I was missing this function that I implemented later on when I was like, well, when I really break it down to its components, I was like, this is obvious. But at the time, I was trying to figure out in one formula or one way of doing it, which was not right. And if you look back at the code, you'll see that was clearly not right. But the idea, the main observation, the hardest part about this problem probably is noticing that, and I think in the examples they give you like they put it in between houses, but the answer is you don't actually need to care about between houses, because let's say here you have to decide between 5 and 12, and you know, do you put on 5, do you put on 6, do you put on 7, do you put on 8, do you put on 9, and so forth, right? And the answer is actually it doesn't matter. And what I mean by that is that, well, everything left of the 2, let's say the 2 and the 3, how do I say this? What I mean is that how do I say it? So I'm just trying to think about a way to explain this. Let's say we want this for 1, right? What is the answer? What is the best way to put it? 25? Don't know what that means. But the idea is basically that if you were to choose between 5, 6, 7, 8 all the way through, it always makes sense to either choose 5 or 12. And what I mean by that is, let's say you're choosing between 5 or 6, right? Well, there are more numbers to the left of 5, so it always makes sense to choose 5, right? Well, in this case, it's not true. But okay, let's just say we have more numbers, and obviously we sorted first. I don't know if I mentioned that, but let's say we're choosing between 5 and 12. Well, here, let's say we choose between 5 and 6, right? Well, if it's 6, then if it's 6, there's 4 numbers to the right of it, 3 numbers to the left of it. So versus 5, well, 5 has 2 numbers ahead of it. So we definitely want to go 6. And then you could use that same logic for 6 and 7, and then 7 and 8, and all the way through. So all the way up until 12, a critical point, if you will, where it may change, because then now you have to change the equation of what's on the left and what's on the right. So knowing that, making that observation, which I had known beforehand because I practice on similar problems, from that, you know, that you always want to put a mailbox inside a house. Okay, so now we simplify the problem a lot, and the question becomes, okay, given these houses, which k of them do we put a mailbox, right? Well, here we then just do dynamic programming, where the state is this is the number of mailbox left, and this is the place to put a house. Well, what is the best case where index is the last house? I think that's what I want to say. And there are a couple of edge cases for sure, but the cases to break down. But basically, let's say we already have a house. So this kicking off function just gets the first house. It's like, okay, this is in essence a brute force of, okay, let's try putting a house here, and then the rest, you know, it's a subproblem, we ignore it. Try putting a house here, the rest is a subproblem, we ignore it, right? And so forth all the way through. And then now let's say we have a house, let's say the index is on 5, and we do this recursion on get min. Okay, now let's what our recurrence is. Okay, let's say we put a house on 18. What is the cost of putting a house on 18? Well, 12 will have to choose between 5 and 18. 20 you have to choose between 18 and I guess nothing, but which is how well, 20 has to choose between 18 or a future house, or a future recursion, and that's what this recursion does after we put down a house. So basically that's all we do. So this cost2 function basically just gets all the numbers that are in the middle, and then the cost of all the numbers in the middle is whether it goes to the left house or the right house. And then we iterate through that. So here, let's say we have 20, 18 will go to 20, so the cost is 2. With 12, the cost is 7 because 12 is closer to the last house, which is 5. And then we just do it the entire way. And then at the very end, if we have any house left over, then we just go to the previous house, which is what this does. So those are the two houses. the two cases, and then now the cost 2 is just like we said. The left house is here, the right house is on the index, and then for each house in between those two indexes, we just see which one is closer, right? Is it closer to the left or is it closer to the right? And that's the cost function for that. Yeah. Okay. And then, so that's pretty much it for this problem. I mean, it's easier said than done. So let's analyze the complexity, right? Well, how many states are there in getMin in this function? Okay, well, index can be from 0 to n, and k could be also from 0 to n. So the number of states is n squared, right? Or n times k if you want to be more specific, but because k doesn't have to go all the way up to n. But I'm just thinking about worst case scenario in terms of, well, can we implement this, right? And then here we also go from index to n. So this is also, because we have a for loop of O of n, each element takes O of n work. So this is equal to L of n squared times k, or in the worst case scenario, O of n cubed, right? And then you may ask, well, don't you have a cost2 function here? And this cost2 function does a for loop, right? Well, so there are different ways to do it. So there are different ways to figure out how to do the math. So another way you could have done it is just by writing this. But let's just say because we have a lookup table, we cache it. This is O of 1. We'll get to it in a second. And since this is O of 1 because we already have a lookup table, then the work is still O of n. Otherwise, it's O of n times O of whatever this cost is. And in this case, it's O of 1. So this is O of n. That gives us O of n. And then this gives us n cubed time. And for space, well, the space is much easier, right? It's just n squared because that's the number of possible inputs. And for each one, we save one copy. Cool. And then now we have to get to this. How do we make this O of 1, right? Well, it's O of 1 core. After you finish doing everything, this is O of 1. Because, and this was not necessary, by the way. I noticed this afterwards that we only called it here, which is the inverse of this, but I'm not going to change the code. It's fine. During a contest, I mean. During cleanup, you should clean up your code. And when you're in an interview, try to keep it as clean as possible. But yeah, but here we do a similar, you could do it with a pre-calculation with for loops. Because for example, you could, instead of doing this, you could just have like for left in range of 0 to n, for right, or for index in this case in range of 0 to n. And then you could put this for loop inside here and then and just populate it, right? So you could have done something like this. So this is also and then like a cache of left index is equal to total, and then this one would just be a cache lookup, right? So I was a little bit rusty on this one because I struggled with trying to do it in linear time. I knew that I needed to do this, but I was trying to figure out how to do it in a constant time, and I forgot that I should just pre-calculate this. That's what a lot of my timing went to. But yeah, so this is converting this to this. But how would you analyze this as complexity? Well, same thing as here, right? So left can be from 0 to n. Index can be from 0 to n. So this is O of n squared states, and each core does O of n work because there's an n for loop, and these operations are O of 1. So each of these have O of 1 work. O of n work. So that equals to O of n cubed. And because your algorithm is going to be n cubed anyway, this is fast enough, and doesn't really worry about it. So yeah, so that's the running time complexity, and obviously also this is n squared space. Let me know in the comments if you have a question about that. But yeah, but that's all I have for this question, it's a really hard interview question because there's a few things that you have to realize and learn. I don't think it's a fair question for an interview. It's a little bit hard. In terms of competitive programming, it should be straightforward. I took a long time. I took about 40 minutes on this problem with a wrong answer. And I felt like, to be honest, I got most of this, but I was missing this minor thing with the optimization because I was trying to put it in 2 for loops, and that would make it end to the 4th total, because here, if we had a for loop, then this would be n squared, and then this would make it n to the 4th. But then I remembered that, I could just save it, and that took way too long, unfortunately. But yeah, that's what I have for this problem. Let's take a look at my contest results. Top 200, maybe okay. I think it doesn't include the China server, so it's gonna be a little bit lower than that. But yeah, I just had a lot of silliness. But hopefully I'll do better next time. There's a contest later today. Let me know what you think. I'm a little bit tired. Oh, I guess actually, because I this went so long that I'm able to do code review, so I'm going to do a code review real quick. Yeah, I'm going to do that. Cool. Let's do a code review. Q1. Which one is Q1 again? Oh yeah, that's just the brute force. Yeah, I did a brute force. Anyone did it in linear? No. Now just brute force. Okay. Yeah, for easy problem, everyone did in 2 minutes. No one's going to think about it too much. So yeah. Cool. All right, Q2. Yeah, I don't think I learned that much from Q1, but yeah, I just did this brute force as well. Oh, this is smarter, but basically, yeah, just push thing in the stack and then return the first entry that goes through. But apparently that optimization isn't even necessary, which is a little bit sad for them. But yeah, this is what I did. Okay, I mean, I think those are the things. Q3 had a lot of off by ones, but overall sliding windows with segment stuff and events. Yeah, basically did the same thing that I did here. Yeah. I mean, I discovered it the hard way, but otherwise it's the same thing. This is much. I was thinking about doing something like that with dynamic programming lookup instead of sliding window. Maybe that would have been better. Not sure. But the idea still is that, and I think this is cleaner because then you know that how to handle the segments a little bit better. But yeah, but basically you just return the best of the previous one. Okay, I mean that's essentially what I did actually, except for that I just did it with the sliding window. I did a track that does the same thing. But you know, even though I was really slow on this one, it seems like I could have been on par with a lot of people's submission if I did the Q4 really fast, but I didn't. So, and I even got a wrong answer because, yeah, I mean, it is what it is. Okay, let's see how you did it with bottoms up. Primitive. So basically, did with prefix sum. Oh, I was thinking about this solution actually, the divide and conquer solution. Yeah, same thing. That's not readable. I guess I did it a different way than they did actually, but they did it with a. I was trying to think about that binary divide and conquer solution, but yeah, I guess that makes sense. I don't. I think what I was. Yeah, I think my issue was that with dynamic programming is I got stuck in one particular way, so I didn't go back to that algorithm of n cube of divide and conquer. I did think about it, but then I thought that I wasn't sure that you. So I made that observation before I made the observation about whether I need to be on. Like, do I always have to put a mailbox on a house? So I was like, oh, can I do divide and conquer? But then now that I think about it again, if I had gone back to it, then yeah, of course I could have done dynamic program from on the houses because you just put them on the house. Yeah, oh well. Yeah, so definitely possible, but that's cool. Did learn something. But yeah. Cool. That's what I have for this problem. That's what I have for this contest. Let me know what you think. I mean, I didn't do that well, but sometimes that's okay. The learning is the important part, and I did learn on Q3. I learned a little bit, especially looking at people's code. And Q4, I still learned. And I think one thing I want to say is that it's even when you get things correct, and even when you submit things, and even when you think you know how to do it, it doesn't mean your learning has to stop there, right? You can learn from other people's code how they did it. The different algorithms, especially for Q4s, and different tricks that you may look at and be like, oh yeah, these are the things. So definitely, don't give up and keep on going. Yeah, I did it the same. Alex did it the same way I did, except for that he was not, dumb. um, hmm. Oh, he did it with O by O of 1, which is a for loop, which is what I did it. That makes sense, actually. Cool. Yeah, so yeah, definitely still opportunities to learn. So definitely, yeah, keep on going. And hopefully next time I'll get back to the top whatever list. I've been kind of not doing that well that hot lately. I'm still, my excuse this time is that I'm suffering a little bit from jet lag. I'm just got back to New York, so you can see the background. Welcoming me back is finishing not that well, but still, yeah, I mean, I was way close. I have to kind of look at the records to see what time I did this, but because even if I look at this, right, yeah, I had like this is 30 minutes of out of 40. So I got the wrong answer really quickly in 10 minutes, and I spent 30 minutes trying to figure out this piece. If I had this piece, and I mostly would have been done. So yeah, and if I had done the Q4 in about, let's say, 20 minutes, so I have 40 minutes plus even 15 minutes penalty, that's like 55 minutes. Even 55 minutes penalty, I would have been top 100. So still could have been better though. But yeah, just a lot of more practice. I've been a little bit rusty because I've been jet lagged. But anyway, these are excuses. Hope you did well. Hope you had a great contest. Let me know what you think about these problems, and I will see you later. And I'm going to do the later contest today. So hopefully I get back to being good very quickly. Or whatever. Anyway, see you later. Bye bye.